Hey guys, Mr. Drum here. It is time for another wonderful video from the world of pre-cal. I'm sure you all are excited about that. We are going to finish up the notes that we didn't get finished on Friday from the exponential functions and graphs. Okay, so if you have those 3 pages printed out, there's some stuff that we want to go over. We did the graph, of course, of exponential growth, but we didn't talk about any transformations or anything like that. Well guys, as it says right there on your notes, it says the graphs of exponential functions follow the same rules of transformations as other functions do. And then it's asking you to identify the transformation of each function. So this is something that I think that you guys can handle, but I'll give you a hint. Number 1, okay, f of x equals 2 to the x plus 1. That is just like any other function. That would be up 1. You're adding to the outside of the graph, okay? Number 2, f of x equals 2 to the x minus 3. Well, hopefully you would realize that that's just simply down 3. Okay. Number 3, this one, the function is that you're making the change to the function itself, so it's inside the function. So this is a change in the left and right direction. And remember, if it's on the inside, it's going to be the opposite of what you think. So plus 1 you would think to the right, but it's actually left 1. Wow, that is like a horrible writing today. Okay, left, there we go, 1. All right, number 4, 5, and 6. I'm going to leave for you guys to answer here on this little play pause it video. So 4, 5, and 6 you need to answer now. Okay. Exponential decay. Guys, the graph, I mean, you have a graph on your paper and things like that. It's going to look pretty similar to what you've seen before. Now, keep in mind that our base now is a fraction between 0 and 1. Okay, so in this case, we have a base of 1/2 to the x. So let's just choose our similar numbers, -2, -1, 0, 1, and 2. Okay, 1/2 to the -2 power. Okay, well, that's the same thing as 1 over 1/2 squared. So 1/2 to the -2 is the same as 1 over 1/2 squared. Well, that's 1 over 1/4, which is just simply 4. So you have the point -2, +4. The next one's a little bit easier. 1/2 to the -1 power, well, that's just 1 over 1/2, or just plain old 2. So you have the point 2. 0, anything to the 0 power is 1. Okay. Now 1, what's 1/2 to the first power? Well, that's simple, that's 1/2, and 1/2 squared is 1/4. So basically your graph kind of does this. It comes down, we have a point at -2, -2, +4, then we have a point at -1, 2, then we have our friend 0, 1, then we have 1, 1/2, and 2, 1/4. So in other words, we are decaying at a rapid rate. The only thing that's different about decay is that it's flipped. Okay, you're coming. If it's a decay function, you're going to go down. So the limits, okay, or the end function. So as x approaches infinity, the limit of f of x is going to be 0, and as x gets bigger in the smaller direction, as it approaches -infinity, it's going to be +infinity. And again, we aren't going to cross over 0. Okay, so now what I'm going to do is I'm going to allow you to do the other exponential decay function. I'm going to allow you to identify the transformations because, again, the transformations are just the same as any other transformation rule that you've always had. So there's 3 questions there that I would like you to answer in your notes, and if you have any questions, we can talk about it when I see you tomorrow. Okay. The natural base, E, guys, you have a calculator. You can graph it. Basically, what they're trying to get you to see there is that the natural base, e to the x, is just like any other exponential function, but there's a special point to it, but I'm not going to worry about that at this point. Okay. So next on your notes is the compound interest. Okay. There are a couple of different formulas that you're going to have to write down. Okay. But just, as far as in general, how do you find the amount of interest that you get? Remember that interest is the principal times the rate times the time. Okay. Well, in the example in your notes, you were given $1,000. Okay. The rate that you're given is 5%, so you need to write that as a decimal, so that's 0.05. Please do not put 0.5. If you did 0.5 at a bank, you'd be fired. And then the time, well, it says it's doing it every year, so that's going to be 1. So how much interest are you going to get on that $1,000? Well, you're going to get 5% over a year, or $50. So how much do you have after 1 year? Well, you have $1,000 plus the $50. So after 1 year, you have $1,050. Okay. Well, then the next year you start out with $1,050. You do the 0.5%, and again, it's just for 1 year. And at the end of that year, you end up having the amount of interest is $102. Well. Okay. The amount of interest that you get is not $102.50. It's more like it's $52.50. But you add that to your $1,050, and you get $1,102.50, and so on and so forth. Now remember, this is money. Round up if you can. So, for example, when you ended up with $55.12.5 the following year, round that up to $55.13. All right, and you just keep going from there. Now that's if it's compounded annually. Now there is some times where it's like, oh, wait a minute, I'm not compounding annually. Okay, there are going to be 2 different things that you're doing. Okay, so if you have more than just one compounding per year, this is your formula. Okay, this is under your notes where you have P, R, T, and N. Okay, and it tells you what they mean. Here's your formula. A, the amount that you have, is equal to the principal times 1 plus the rate divided by the number of times that it gets compounded, raised to the number of times it gets compounded, times T. Okay, that should help you with your homework at least, having that formula. And again, that's like if it's not compounded interestly, okay, or continuously. My bad. So this is for not continuous compounding. Okay. Now, if you have continuous compounding, that means it compounds, on a daily basis, or hourly, or every second. And if you find continuous compounding somewhere, let me know so I can put my money there. Not that I have any money, but anyway. Okay. This is where that lovely little function e comes into effect. Okay, I'm sure you've seen this before. Here's your formula: a equals p times e to the RT, okay, where E is the E value that you're just looking about, the natural base. Okay, it's like 2.7, something like that. Okay, I'm going to let you do the examples that are at the bottom. Make sure you see quarterly. By the way, quarterly means what? That means 4 times a year. So for the first example, A, N is going to be 4, because 4 times a year. B, monthly. What's N going to be there? Hopefully you all are screaming at me it's 12, because there's 12 months in a year. And then continuously for part C, you're going to use the PERT formula. For part A and B, you're going to use that. Given, of course, the stuff that you're given. $25,000, 8.25% interest. Oh man, wish someone had done this for me. And then the child's 26th birthday if the interest is compounded quarterly, monthly, and of course continuously. Hopefully you realize that the continuous one would give you the most money. And I'll let you all figure that out. All right. Now there's one other thing that's not on your notes, but we do need to talk about it. Okay, and that's called one-to-one. Okay, or the one-to-one property. This is actually very straightforward property that makes life a lot easier when you're trying to solve these things in general. Okay, so let's say, for example, that I want to solve for x. Okay, I'm not even going to discuss what the one-to-one property is or what it says or anything like that, but I'm going to show you how to use it. So I have 3 to the x plus 1 is equal to 27. Now what the one-to-one property says is if you have the same base, okay, then the exponents have to be equal to each other if the equation is equal to itself. Okay, so my base here is 3, so I have 3 raised to the x plus 1. My base over here is 27, but I can convert that to base 3 because I hope you understand that 3 cubed is the same thing as 27, because 3 times 3 times 3 is 27. So I'm going to take this 3 to the x plus 1, and I'm going to rewrite 27 as 3 cubed. Now I have the same base. 3 and 3 are the same base. So if these two statements are equal, that means that x plus 1 has to equal 3, or x has to equal 2. And that's all the one-to-one property really is. Let's do a couple more examples of that. Okay. So we have 1/2 to the x power is equal to 32. Well, again, we want the same base. How can I get 32 to the 1/2 base? Well, I know that 32 is equal to 2 to the 5th. So I know that I can rewrite this as 1/2 to the x is equal to 2 to the 5th. Oops. This should be a 2. Is equal to 2 to the 5th. But that's still not the same. But I can change this 2 to the 1/2. How can I do it? Well, 2 to the 5th is the same thing as 1 over 2 to the negative 5, right? Well, that's what I've got. Okay, so I can say this is the same as 1/2 to the x is equal to 1/2 to the negative 5th power, or x is equal to negative 5. Those are a little tricky. You have to understand, what a negative exponent means and things like that. And I know that, you talked about that a little bit, but not a whole bunch. Okay. So let's do another one. We've got e to the 3x plus 2 is equal to e to the 3rd. Well, I have the same base, e, so that's nice. So I have 3x plus 2 is equal to 3. Oh, that means that 3x is equal to 1, or x is equal to 1/3. Not too bad, huh? But what about something like this? E to the x squared minus 3 equals e to the 2x. Again, you've got the 1-to-1 property. I have the same base. That's a good thing. So I've got x squared minus 3 equals 2x. Well, that's a mess. No, it's not. You guys know what to do with this. X squared minus 2x minus 3 equals 0. Factor it. X minus 3, x plus 1 equals 0. X equals 3, and x equals -1. So I've got two choices, okay? All right. So guys, that's it. That's the 1-to-1 property. I told you I was going to try to keep this short, and I think keeping it to about 16, 17 minutes was pretty good. You know, there's going to be a little bit added because I did the other stuff. But anyway, have a great day, and I'll talk with you all tomorrow.